All right, so this is a little bit difficult to take a video of, just freehand, but this is the Rebel 1100. Look a little worse for the wear at the minute, but it'll be better soon. This is the suspension side. That side, the brake side, that is not. That is just a spring. Some people think that it does something because it has a damper rod in there, but I've talked about this before. There's just huge holes, so it may do some amount of compression damping at very, very high speed impacts. Like if you hit a curb doing 70 or something, it might do something. But other than that, it doesn't. This thing's a pogo stick. You can take it off yourself feel if you want. There's no damping going on here. It's just a pogo stick. That's it. So yeah, if it really collapses really, really fast, it might do some tiny amount of compression damping. It can't do any rebound damping at all. So this guy, the non-brake side, does both compression and rebound damping. You can feel this too. I can feel it when I'm pushing down, I can feel it when it's coming up. So I took this apart previously and filled it up with, instead of the 10 weight oil that Honda recommends, I did 5W30 weight oil. Phone's kind of freaking out. I don't know why. I did 5W, much thicker 5W30 weight engine oil. It was better for rebound, but it had too much compression damping. So I'm gonna take this thing apart. I've actually got some Matrix dampers, but turns out my steering my headstock, my steering stem, headstock, whatever you want to call it, is bent. So I gotta wait for a new one. So actually what I'm gonna do, before I install the Matrix dampers, I'm going to take the O-ring. I'm gonna take this thing apart, take the O-ring off the compression piston, fill it back up with much thicker oil. I've got some 15W50 engine oil here, and put it back together and see how it feels. So basically this with 5W30 is too much compression damping and not enough rebound damping. Since rebound and compression happen the same leg with the same oil. You get thicker oil, you get more of each. That's not really what I wanted, and it turned out there was too much compression damping. So by removing the O-ring around the compression piston, I'm hoping to mitigate the rise of compression damping and get more rebound damping out of this leg. So I'm just curious how that works. Figured I'd let people know, even though I'm not going to be doing this permanently, because this is my wife's bike, and she deserved me actually spending some money and getting the Matrix ones. But if you want to do a cheap upgrade, I think this would work pretty well. Like I said, it already does work well with just the thicker oil. Just the compression damping is a little too much, so when you hit little bumps fast, it kind of is a little jarring. But I'm going to try that with a thicker oil and taking off the O-ring, because that's just labor, really. It's basically the cost of labor and oil, which is like a quarter of that oil is, I don't know, like $4 or something. So I'm going to try that, see how it feels, and come back. All right, and for anyone who's unfamiliar with them, this is the damper cartridge. I always get rod cartridge, but this is the cartridge shaft all the way up that is inside. All we do is we unscrew this bolt right here that is at the top of the fork, and then there's an Allen, I think it's still in there, in that hole right there that you unscrew from the bottom. So then we have this, and when we flip this upside down, on the bottom, this here is the compression piston. I'm not going to be able to do this really with one hand while holding the camera, but if you just push it down, there's a little snap ring in there. So it's just a little, it's not really quite I guess it's technically a snap ring, but it's a little clip. You just get some little hooky type guy. Sometimes you can get it with your fingernail. Oh, wait, I might be able to get this one with my fingernail. You can kind of see how I've sort of pushed it part of the way out of the groove. All right, let me see. So it's kind of sideways in there. Let me see if I can pull this off. Usually you would slide it out of the groove, then get some little hook or, you know, something, whatever you got, and take it out. And then to get it out, then you would just thread a bolt Try and do this while holding this camera is not easy. You would just thread a bolt in there and pull up. Nope, it just snapped right back into place. So I'll pop that out and be back in just a sec. All right, so you got the little clip out right there. Like I said, we just thread a bolt into this guy. The piston, we flip back and forth. Sometimes there's a little galling in there, especially it seems like if you bottom out the bike. Actually, give me just a sec here. All right, so like I said, that thing was a little stuck in there, possibly because this bike had been in an accident before and the front forks had a bit of an impact. So there might have been some bottoming out or deforming or something. It took a little weaseling, but it got out. So what is happening here is this is the compression damping piston. This is actually the threaded part, the Allen bolt, the Allen head bolt right there actually threads into that hole. So this sits at the bottom of your fork like that inside this tube actually, because this is right side up and the fork is upside down. So what we're looking at here are these are the valves that allow fluid to go by and control damping. The problem with this is, and you can always tell by the feel, so these shims are made to control the oil flowing through the whole valve body here, and that's what controls your compression damping. So one side is a bypass valve, and you can always tell which side it is because when you put your fingernail in it, even if you don't think about which way the oil is flowing, if you just put your fingernail in them, see how this one, there's like no tension? So that's the bypass side. So oil goes through there really easily, which means this is the compression side right here. So if we wanted to lower our compression damping, the normal way would be to redo this valve stack, this shim stack. And we could do that, and you can do all sorts of things, fancy things with shim compression stacks. So we could do that. We could take out this bolt and we could redo the shim stack. And you can do, I'm not even going to get into it here. You could look up Race Tech stuff. They have a lot of really cool stuff on shimming valves because you can do compressions at different rates. So it provides different amount of damping based on how fast and how hard you're hitting a bump, all sorts of stuff. Anyway, so the normal way would be to reshim this stack. So we would take out some of these shims so it wouldn't have so much compression damping. If you notice though, we could actually do that with this. There's more shims than I thought. For some reason I was thinking when I looked at this before. When I did this video before, honestly, I was thinking of it the wrong way for some reason. So there are more shims than I thought in here, but that's still not a ton of shims to work with. And you don't want to go too few on the shims because otherwise you're going to be in a section where they're going to be compressing too much with thick oil. So the cheesy way that I'm going to do this is in order to keep the fluid actually flowing through the valve, we have this O-ring here, right? I'm just going to remove the O-ring, a simple way. So like I said, you could reshim this stack. You could do it by taking out some shims, changing to different diameter shims. See how there's a couple here that are slightly smaller? So you could change the profile of the stack and all sorts of stuff I'm not going to get into. Okay, since I'm not in a huge hurry and I had it apart this far anyway, I thought I'd disassemble the valve. So this is the valve body right here that I've clamped in a rag and a pair of vice grips to unscrew this portion, the screw. The shims, the way these work, like I said, the shims get stacked across the valve, which is right here. They act as the gateway. So in order for the oil to be pressed through, it has to deflect these shims. So the more and thicker these shims are, and the thicker the oil, the harder it is, the more compression damping you're getting. If you have more shims and thicker oil, you're getting more compression damping. If you take away some of these shims, or in this case, the O-ring that goes around the outside of this valve that allows oil to escape past the valve without going through the shims, the less compression damping you're going to get. So you can also do fancy things, and if you want, like I said earlier, you could look up on Race Tech about shim stacks. If you want to get into that, there's all sorts of complicated stuff. So you can use shims of different thicknesses and different outside diameters because they'll cause more or less flexing under different circumstances. It can get really, really complex with compression damping. I'm not trying to get there, but if you want to, you can look up compression damping shim stacks on Race Tech or other places. And you can go down that rabbit hole as far as you want to go. In this case, each one of these shims is 0.15 millimeter thickness. And the first, all but the last two, so what is there? The first 5 are 17 millimeter outside diameter. And the last 2 are 16 millimeter outside diameter. And they're all 6 millimeter inside diameter. So all 6 millimeter inside diameter, all 0.15 millimeter thick, and the first 5 are 17 millimeter outside diameter and 16 millimeter outside diameter for the last 2. This is just kind of a little shim here, and this is the plate that this guy sits against at the top. So this side goes against here, one, then on top of him, then each of these in order is on top of them. And then this screws onto the top just like that. Or, you know, if you want to stack them this way first for the bolts or whatever. If you do disassemble this and decide to play with the shims, it'll give you an idea of how they came apart. Also, if you're going to do this, make sure before you reassemble this to put Loctite on this side. So you want to put Loctite on this bolt. And then it's not very much how hard you want to screw it shut. I think it's usually like 30 inch-pounds or something, not foot-pounds, you'll rip it apart, but it's like barely tight with a 1/4 inch ratchet, basically. It's like 30 inch-pounds is what I've seen from other places before. I don't know if that's the exact spec or if Honda even has one they released to customers, because generally it's not considered that you'll be taking this apart. You would just replace the whole thing, but if you want to change how it works. So yeah, anyway, thicker oil for more rebound damping, because the bike is very low on rebound damping from the factory. And then to counteract more compression damping, to avoid the compression damping raise, you can remove this O-ring, you can remove some of these shims. So for instance, you could say, hey, I really want to try to back off my compression damping because I'm going to be going real thick on the oil. And also on higher quality stuff, this isn't how you would do it. On really high quality stuff with very close manufacturing tolerances, you could shim the rebound side for more rebound damping. The thing is, on these parts, Honda uses some kind of low quality stuff without real tight tolerances. Part of probably why it was hard to get that out. So what happens is you kind of hit a limit for how much damping you can get, because what you're doing is you're trying to make that fluid flow through the valves, and if you're stacking the valves too heavy, the shims on the rebound piston, which isn't here, it's still outside. If you're trying to get more rebound damping by stacking more shims on the rebound side, what you're going to run into is eventually those seals, more oil is going to be getting passed, and it's just going to be wall. So things are going to be leaking by the kind of more relaxed manufacturing standards. So that's why with the stock stuff that's not super high tight tolerances, I tend to just go thicker oil, because thicker viscosity, if there's low tolerances, you can jack up a lot of damping with thicker viscosity, and then you can back off compression damping by removing shims and O-rings and stuff like that. So that's kind of why I do it. If you're dealing with some high quality Olin stuff, this isn't how you would do it. What you would do is you would add more shims to the rebound side to get more rebound damping. But like I said, since we're kind of dealing with stuff that isn't as high quality, and also the real benefit of using thin oil is thin oil tends to keep the same viscosity as across heat ranges. So for racing, this is really important because you want consistency, right? But when you're talking about a street bike that's not, the oil in these forks isn't heating up that much. they're right out in front. You're dealing with aluminum and steel. They're getting cooled pretty well. You're not like hammering bumps all the time, hopefully. So in a race application where there might be a wide range of temperatures, we want to use really high quality, very close fitment parts and really thin oil that keeps a very narrow window of viscosity. If we're dealing with street bike cruiser stuff, where we're just like, okay, we want rebound damping in the ballpark because it's way off right now. It's way too low. There's not enough. It is often easier just to use a lot thicker oil, even though that oil will have a wider viscosity change over temperatures. You're not going to see those crazy temperature swings on a street bike usually. And really anything's going to be better than what you're doing. We're not looking for perfection here, but we're just looking for pretty good. So as I said, you could remove some shims. I'm going to leave them in place right now because I don't want to take this thing apart again, and I want to keep it as simple as possible to see what it feels like to begin with. And I want to keep everything together when I take these apart and put them in a box, just in case I sell the bike and I want to put the stock parts back on, or maybe I want to just sell the stock parts or something like that. We'll see how it goes. But I want to kind of keep everything together, so I'm just going to remove the O-ring. Like I said, you could remove a couple of these shims as well, 1 or 2 or 3 to lower compression damping if you're jacking up the oil viscosity. But I'm going to leave it together as it is and just take off the O-ring and we'll go from there. All right, I'm going to put that all back together, fill it up with oil, and see how it goes. Do I want to do that? Yeah, I'll just do it like that. Let's see how it goes. Reassemble it as stock, just no O-ring, and go. Let's see. All right, so real quick, this valve is back together, except this is exactly how it was stock, except for the O-ring is currently removed. Do make sure that there's not a gap or anything. There's kind of a shoulder on the bolt that these little shims sit down on. So make sure all of them are down on that shoulder. There's no gap or anything. When you put your thumb in here, and you can kind of see what I'm talking about. So the oil flows through these passages one way. This is a one-way valve, basically. So when the shock is rebounding, oil flows back through that way, through this really easy valve here. You can always tell, like I said, you can always tell which way oil is flowing through a valve because this is the just oil freely flows back side. And this side right here is the compression side. So in order to provide that compression damping, oil is having to flow and deflect these shims. It's having to flow through passages that are right here. It flows in through this direction. It flows this direction, in through here and out through this really easy to manipulate shim. And when it flows through the compression side, when it's actually doing the compressing, it flows in through this gap over here and out through a hole that's being covered by this shim. So in order for the oil to flow through, it has to deflect these shims. So yeah, fewer shims or thicker oil is going to give you more damping. The only difficulty, like I said, is that since you're doing rebound damping and compression damping in the same leg, if you want to increase your rebound damping and keep your compression damping from getting out of control, you've got to do something to reduce that, to allow that oil to flow through easier. Probably looking at this, like I said, if I was doing this, I'd probably remove a couple of those shims in addition to removing the O-ring, but we'll see. We will see how that goes. Because I'm jacking up the viscosity a lot because the rebound damping is really poor on this bike. If you've never seen it, Dave Moss has a bunch of videos. Basically what you want is when the suspension fluid's warmed up, which it doesn't warm up that much with a street bike, especially not a cruiser like this, unless you're really hitting a lot of bumps and the suspension's going back and forth and causing a lot of friction. But what you want to do is when you compress it hard and release it, you want it to pop back up and stop. You don't want it to bounce a bunch of times and you don't want it to come back up real slowly. So that's really perfect, is you're just removing the spring oscillations. You don't want it pogoing back up and forth like this, but you also don't want it really slowed because that'll cause different handling problems. So you push the bike down from the handlebars, and then just let off and see what it does, and it should pop back up and stop, or come really, really close to that. So pop back up quickly. You don't want it real slow. Pop back up fast and stop. So that's really what we're looking for here, is just to get that amount of rebound damping and not get our compression damping out of control. Because compression damping is what is slowing down, more compression damping is slowing down those forks from compressing. So if you have too much compression damping, when you hit a little bump, it's just gonna rattle your teeth. It's gonna be like your fork springs are rock hard, because it's just gonna be trying to push all that really thick oil through valves that were made to flow thinner oil. So that's what we're doing here. We're trying to increase the rebound damping to get enough, but keep the compression damping under control. So we're gonna put this back together and see how it feels. I do have a suspicion it's not gonna be enough, and I'm not gonna put the whole bike back together because, like I said, I don't have a steering stem, but we're just gonna feel it and see what it feels like. And, we'll go from there. All right, so again, we have this reassembled, the pistons in there. Make sure you do not forget this little clip, and it's all the way snuck into that groove. I know it's kind of hard to see here, but that little clip is very important because it keeps the piston from coming out. So you really need to have that in there. That's incredibly important. Do not forget it. So you put the piston in, then you put the clip in, and now we're gonna reassemble this with new oil, and we'll be back in just a second. I know I keep saying, okay, I'm gonna fill it all, reassemble it. So a couple tips. First of all, make sure the preload is backed all the way off when you're trying to reassemble this, because you're trying to compress the spring and screw it back in. And you're probably gonna have to do that twice, because, and if the preload's all the way off, the spring won't have any preload and it'll be easier to screw in. Because usually what you're gonna have to do is assemble a fork to have enough pressure pushing that thing up to get this bolt started. And even then, what's gonna happen, since there's nothing holding that piston in place, until it bottoms out in there and is kind of holding the piston against the inside of the bucket and everything, it's gonna just spin freely. So I could show you that if I had more hands or a tripod, but I've got this started, but it's just spinning freely. So it really helps to have something mechanical, a drill or something going on to spin it real fast in order to get it to set. So you don't want to tighten it with something like a drill, but it does help to have it spin fast. So you can take a drill like this. This is a 6mm Allen wrench that I've just chopped the end off of, so I can chuck it up in my drill. And then what I'm gonna do is, I don't want to tighten this with the drill. I just want it to go really fast until it bottoms out. So I'm gonna turn the clutch down on the drill a lot, so the clutch will have a really low stall. So that's what I'm gonna do. I'm just gonna try to get that started, and then once it bottoms it down, then I can tighten it by hand. And at that point, once this is tightened down, then I'll take that end off, fill it up with oil, pump it a bunch of times in order to get the oil set in, and then we'll test and see how it feels. All right, so we got the fork back together. This is, like I said, this is the damping side. This does compression and rebound. The brake side, it maybe does a little tiny bit of very, very high speed compression damping. It can't do any rebound damping at all. So don't worry about that side for damping. It's just really not in the conversation. So I've reassembled this. All I did was take the O-ring off the compression piston. Other than that, it is as it is in stock form, and filled it up with much, much thicker oil. I used Mobil 1 15W50 weight engine oil, advanced full synthetic. It's good stuff. I think you get a jug of 5 quarts of this stuff from Walmart for like 27 bucks. I use it in most of my engines. Great stuff, especially down here in South Texas or somewhere else where it's really, really hot. I pretty much ignore viscosity recommendations. I just put in the thick stuff because it's hot down here. And honestly, I see nothing but benefits. So anyway, that's it. Taking off the O-ring around the compression piston at the bottom, filled it back up with 15W50, and it feels really good. The rebound damping, of course, I won't know because I'm not going to put it back on this bike as is, but feeling it pressing down and releasing, that feels way better than stock, guys. That feels much closer to what it should be. You can kind of watch the line right there. I realize it's hard to do this because I'm moving, I'm pressing down, but that rebound damping, feeling pretty solid. So I think this is good for the rebound damping. The compression damping, this is my wife's bike. It still feels like it might be a little too heavy. So for her, I would probably have removed one or two of these shims if I was gonna go with this oil to reduce the compression damping even more than just removing the O-ring around that piston. So as I would like to say, everybody who is like, oh, it's gonna break things, it's not gonna work. No, but the O-ring just seals around that compression piston. So when you're removing it, you're just allowing some more of the oil to get by that piston. It's not through the shim stack. That's not what you want on really high quality stuff. Like I said before, if you're dealing with Öhlins or something with really tight tolerances, you can have everything controlled by the shim stack. When you're dealing with this kind of low tolerance or high tolerance stuff where it's a little bit sloppy and not super high quality, especially with street bikes where the temperature variance isn't huge in your forks. I mean, they're right up there in the air, they're getting cooled well. You're probably not doing anything super extreme. Keep in mind, moving back and forth, it'd be the thing that would heat up forks the most. Quickly going back and forth. So if you were just hitting bumps and bumps and bumps, just hammering speed bumps going 50 miles an hour or something, that would be the hottest your forks would get. So yeah, I think this stuff, it works pretty good. This feels pretty solid. Definitely this would be an upgrade over factory by a wide margin. This bike did not have nearly as much rebound damping as it should. And honestly, it feels good. Like I said, for my wife, probably would have taken off, my 140-pound wife probably would have taken off one or two of those shims, the 17 millimeter. So had like 3 17 millimeter shims and 2 16 millimeter shims on there to reduce the compression damping further. If you're a heavier person and you're using the stock springs, it's probably good like this. If you're upgrading springs, when you upgrade springs, you want to increase the rebound damping and decrease the compression damping, generally speaking, because rebound damping is fighting against the spring, right? When the spring is rebounding, rebound compression is what's fighting against the spring, holding it in place. So since we want that spring to pop all the way up and stop, if we have a stronger spring, we need more rebound damping. Since compression damping is working with the spring, generally speaking, when we go to heavier springs, we want less compression damping. So if you were going heavier springs, you'd probably want to even go more than this, if possible. I don't know what you would use at that point. Some real honey, maybe some gear oil or something in your forks. I don't know. But yeah, I would say if you're just looking for a mild upgrade for cheap, and you don't mind doing a little wrenching on a weekend, you can get this fork out there pretty easy. I think it took me 20 or 30 minutes to get this fork apart the first time. To get the fork out of the bike. If you're doing the steering stem, especially if yours is bent, that's a lot more of a hassle. But getting the forks out are not that big a deal. So yeah, I like it. I think it would be pretty good. But since I purchased the Matris suspension, I'm gonna put that in. But anyway, I hope you guys found this, hopefully you learned something, or at least found it slightly entertaining, as I clearly got grease all over my floor that I need to clean up. So anyway, thanks for watching. Have fun. Bye. Okay, the last consideration for trying to do kind of affordable handling, at least I think the last consideration I'm going to talk about right now, is the possibility of putting the damper cartridge, that's the stock long cartridge that came out of the non-braking side, into the braking side. So this would be a scenario where if you had got a stock spare damper cartridge pretty cheap, you could double the rebound damping, and you would have to do something to reduce the compression damping as well. But you could basically put a cartridge in each side, because it only comes in the passenger side to begin with, not this side with the brake disc. But you can put one in here. There are a couple considerations though. Mainly is that the end, and this is my Matrix one, so it's scaled a little bit smaller. The stock one right on the end there is bigger. So it will not fit in the little centering cone. So what that means is, first of all, you're going to have to use some sort of a washer, because on the end of the stock cartridge, and I would show you the stock cartridge, but it's currently inside this. So on the end of the stock cartridge, you're going to want to use some sort of a washer, and there's not going to be anything automatically centering it. Let me see if I can get my phone to focus on this. It's really difficult to see. But see how mine's aligned there right now? That's aligned because I took a screwdriver and gently aligned it to get the bolt started in there and make sure it would fit. It didn't start off aligned because there was no little centering cup, because it's too narrow on the inside diameter to fit over the end of the stock damper cartridge. So if you use one from a stock damper cartridge, that might work, but those are reused with aftermarket kits. So what I'm thinking is, if you're someone who's just trying to get a little bit of a increase in handling but not spend too much, you could talk to someone like me, for instance, who got rid of their stock damping cartridge, and you can purchase that and put it in your other fork leg in the brake side. Like I said, you would need a washer to protect the aluminum, because this is aluminum and the outside of that damper cartridge is steel and you don't want it digging in there. So you'd want to put in a washer, and then you would have to align that manually and get the bolt started, and then fill it up with oil just like you normally would. You would probably want to remove the compression ring piston as well, probably on both sides, because this bike doesn't really need a lot more compression damping unless you're a really heavy person, and then you'd want to be upgrading springs anyway and all sorts of stuff. So if you're just looking for more rebound damping, which in my opinion is what these bikes are really lacking, you'd probably take both sides of the suspension apart with a new cartridge, and you take off the compression damping piston off both cartridges, and then you would put back together the stock side that was the stock damper cartridge side. I keep trying to say damper rod, but it's because it has a rod, but it's not called a damper rod, it's called a damper cartridge. So anyway, you would put back together the driver's side as stock, but probably without the compression damping ring, and then you would do basically the exact same thing. You would duplicate that exact same thing over on the passenger side, the side with the brake. The only difference is you wouldn't be able to reuse this cup. Maybe you could if you really drilled it out. I don't think so though. And all that's doing is centering it. So as long as you manually centered it, put a washer on there to protect the aluminum bottom of this fork from the steel shaft, slap a washer on there, manually align it with a screwdriver or something, then put it into place, fill it up with fork oil, again without the compression damping, the ring around the compression damping piston. I think that would probably give you a pretty decent result, even without going to super thick oil. So you could probably use something more like the stock 10 weight oil, or maybe like a 15 weight oil. Nothing too extreme like what I was talking about if you were just trying to get all the rebound damping you needed out of just one fork. So anyway, that's pretty much it. Hopefully you enjoyed these videos. I wish that I tested all of this stuff, but quite honestly, I'm kind of lazy, and as much as I would like to test everything for you guys, I'm not going to disassemble and reassemble this front suspension like 10 times. So good luck out there. I think these options that I gave would be pretty good with my knowledge of Honda suspension and what I've done with other Honda bikes. Obviously, the best option is going to an actual full aftermarket compression damping cartridge like this, so you get full manual control in both front legs. But I also understand that not everybody has that kind of a budget. So hopefully some of these cheaper options I provided are something that may help you guys out, or maybe you just like watching them and find it entertaining. Either way, have a great day. Bye.